Hello and welcome to the Edinburgh Science Festival. There are currently 1,886 man-made satellites orbiting Earth, collecting information and beaming it back to us. But what information are they collecting, and how can we use it in fields like conservation, deforestation and other Earth observation? How can we best use this space-gathered data to help us with some of the biggest challenges on Earth? This event is free for you to enjoy thanks to our festival sponsors and supporters. Edinburgh Science is an educational charity. Please consider making a donation through our website to support the work we do and enjoy the event.
Today we're going to be speaking about satellites. Now, what is a satellite? A satellite is referred to an object that has been intentionally put into space. But the official definition of a satellite is a moon, planet or machine that orbits a planet or a star. For example, the Earth is a satellite because it orbits the Sun. Likewise, the Moon is a satellite because it orbits the Earth. These are often referred to natural satellites. However, artificial satellites refers to a machine that is launched into space and moves around the Earth or another body in space. And this is what we're going to be speaking about today. Currently, there are 2,887 active artificial satellites orbiting the Earth. On October 4th, 1957, Sputnik 1 became the first satellite to be launched by humans, starting the era of space age. The first British satellite to be put into space was Ariel 1, and that was launched in 1962, and was the equivalent weight and size of a dishwasher. However, as technology is continually to rapidly develop, we are now getting satellites that are the size of your hand or even your palm. And here I'm joined today by Dr. Sonali to tell me more about this. What do you think there are some of the current challenges there are with satellites in the UK?
Thanks, Katie. Yeah, that's actually a really interesting question, because in the UK, from the 2000, if we see, like, the UK space capabilities have almost trebled till now. But then there's still a need to kind of build a coherent space strategy. And we are we can see that a lot of good work is going on in that arena. So some of it is to build capabilities in the UK for spaceports. Some of it is to build space tugs. There's lots of new space companies coming up, which we're seeing that we're kind of going away from the model where space was kind of monopolized by governments. But then bigger companies started taking space into their domain, and then now we are seeing a lot of startups going into space, especially with the launch of the small satellites, which people can kind of work in small groups. It doesn't need a lot of money as conventional satellites do, and there's more of a risk appetite, basically. So in the upcoming future, I think in the UK, there's quite a strong capability for building a really good supply chain so that we can onboard new sensors into satellites. And these kind of sensors can be can come with a lot of variety. They can be quantum sensors, they can be used for magnetometry, they can be used to predict space weather events, which we are being told that there could be a significant space weather event in the future. So we should develop those capabilities already. A lot of the satellites are sending up different kinds of technologies to give us information about exoplanets, for example, or what's happening in the storms in some of the satellites of Jupiter. There's also quite a lot of push happening in the satellite industry, especially because I work in the quantum sector. We are seeing the miniaturization of big quantum technologies. Like, I can almost think that maybe quantum computers would be onboarded into satellites in the future, And now we are onboarding different kinds of quantum sensors. And I think what I'm seeing as well is a merger of artificial intelligence onto satellites. So one thing we do at Craft, and it was actually one of our first products, is the forward-looking imager. So with the ROKS mission, we will try and provide secure keys to customers or governments or financial institutions or universities or hospitals or anybody who requires that data to be protected in a more future-proof, secure manner. But then when the satellite is kind of going up on top of a ground station, and I can say that, okay, you're the customer and you have a ground station, and I will send down some keys to you. But what if there's a cloud cover over it? And this is where I'm seeing that a lot of the technologies that can predict climate change are also being used, like light neural networks can be onboarded along with the imager that can look ahead and see if there is a cloud cover on top of that ground station. If there is, then we can automate some of the discussions, some of the decisions on board, so that the satellite can say, okay, I'm blocked towards this ground station, but let me point it in the other direction so that I can still send some of the keys. So yeah, those are some of the exciting things I'm seeing. Definitely lots of spaceports coming on, lots and lots of work being done in the downstream sector, because people are analyzing more and more satellite data, and they're just using it for social purposes as well as for, like, you know, company profit purposes, I guess. And one of the things that I'm seeing as well that I'm really excited about is the international collaboration that's coming together, because going ahead, we're going to be wanting to build a constellation of satellites. For example, the UK has a strong need to find something which is which can take the place of what Galileo was doing for us. And we need to basically build resilience, a new timing and syncing system. And we are already starting to talk with different other countries so that we are making sure that our satellites are interoperable. Rather than sending up a whole constellation by ourselves, we can kind of link existing satellites that already exist by other countries. So
yeah, definitely, and that's, you know, a lot healthier for the environment up in orbit. Paula, did you have anything to add on that?
Yeah, I think that Sonali, you raised quite a few really important points there, just to come back to a couple of them. You know, I think, Katie, when you introduced the question, it was about the number of satellites that are up there right now and what it's going to mean. And I think in terms of climate change and monitoring the environment, it's really that we're living in an age where there's a deluge of information coming, information that we haven't had before. And I think one of the challenges with that is really getting industries on Earth that are operating, that are related to that information and need to make those decisions, up to speed with what is coming from space and what is coming from these satellites, and how they can access it to inform their day-to-day operations, which ultimately affect carbon emissions, land use all over the world, spread of deforestation, all those sorts of challenges. And I think Sonali raised another really important point about the development of satellite technology moving forward, where we're seeing, you know, as an example, in Ghana, one of the countries that we work in, to use satellite imagery to map out where cocoa farms are and where there is agroforestry cocoa, which is grown with forest canopy, natural forest canopy, and where there is sun loving cocoa. And all of this has implications for the amount of biomass, the amount of carbon that is in that supply chain. And Sonali raised the point about being able to see through cloud cover. So I mean, the satellites that we have right now, you have some that are optical, that are taking literal photographs of the Earth at different sort of resolutions. But then you've also got partner satellites, so like ESA Sentinel-1 and 2, where you've got a radar satellite as well. And what radar means is that the satellite is picking up different signals that are reflecting back. So when you've got an issue like a cloud cover, then you can, you know, use a different satellite to say, oh, well, that this signal can make its way through the cloud. So those are some of the challenges, you know, just in terms of a practical example. Ghana is a very high cloud cover country. So that is exactly why they need to use that type of satellite technology. And I think, you know, just overall, the deluge of information and how to use it is probably one of the key things that we need to overcome in the next 10 years with using this stuff to help to solve the climate challenge. So, yeah.
Yeah, that's actually really interesting. I just wanted to add, like, you reminded me of some other things, other exciting things that's happening. I think, like, in the international development perspective, there's the rise of the small satellites, which are cheap, relatively inexpensive. We are seeing that it can be used to provide remote aid, like hospitals, to people who are stuck in remote areas, and education, like to a lot of places which would not have managed to, you know, get the cutting edge education as before. We are using satellites for international development actively around the world today. And I think that's something that, like, everyone's passionate about, because it's bringing about change which is positive, and we're doing it together using technologies for us rather than waiting for the technology to, you know, evolve in its own direction.
Mm-hmm.
Yeah.
I think it's really interesting of what you say, what both of you have said there, and, you know, the different applications of satellites that each satellite has. And I think, you know, the general sort of public in the UK and globally are very unaware of, you know, satellite uses. And, you know, when they hear a fact such as 17,000 small satellites are going to be launched by 2030, and, you know, rockets using fuel and how much, you know, damage that is going to do to our greenhouse gases and our climate change, you know, we need to, promote the benefits of satellite applications. So it brings me on to my next question. With so many satellites due to be launched, what does that mean for the orbit? What does that mean for space traffic? Are there going to be more satellites crashing into each other? Do you think that any, laws or restrictions should be in place for future satellites to be launched? Sonali, I'll bring the question to you.
Yeah, that's another really interesting and very important question. And yes, absolutely. I think we need space traffic laws, space regulations. And I think you're seeing we have had quite a few close misses of satellites, projections being like, okay, is this going to hit? It's not hitted, and it's just gone in its orbit, but they have passed quite close to each other, two satellites. And so with more and more satellites going up, there's quite a few different concerns that we have to address together globally. One is space debris, because there's a lot of tiny objects and a lot of random satellite parts which are going to be lying around in space, and they're going to be orbiting, and we wouldn't have unless we have a way of predicting where the direction of the space orbit, the path, the trajectory, and making sure that they are not crashing into other important satellites which are already in space. And I know that maybe Paula does a bit of work on that one, so maybe you want to talk about that a little bit?
So yes, Sonali raised some really important points about restrictions on the numbers of satellites that are going up into space, and I think that it's not exactly my area of expertise, but in terms of the applications, it is extremely important, because to tackle some of the environmental challenges, you're relying on data coming back day by day, and you have processes on Earth with institutions and individuals who are processing that information. So if the satellite is to crash and then that information isn't to come, then that can cause a really sort of chain reaction onto the sorts of things that we're monitoring, like forests being cut down or forests being degraded. So to have those sort of commercial level solutions to tackle these problems at scale, I think that type of legislation is really, really important. But I know that, Katie, you know more about how to actually get a satellite out of orbit if it needs to.
Yeah, definitely. So what I wanted to speak to you about next is Space Tug, and this is more of what I work on. So I work at a company called Skywara. We're a launch vehicle company, and our job is to transport the satellites into space. And our vehicle has some very cool features. The third stage of our vehicle is a reignitable engine. So it means that it can drop satellites off into different orbits, because satellites need different orbits to collect the data that they need. And this reignitable engine can also act as a space tug. And essentially what that does is that it can fix faulty satellites in orbit, it can replace faulty satellites, it can also remove satellites if needed, but they can also push out satellite space debris into deorbiting graveyards, and they can also bring it back down to Earth. So a recent thing that happened in the news recently was the Chinese rocket that had debris falling out into Earth, and fortunately that fell down into land, but it was very worrying to know that it could actually fall back down onto land and actually harm people. People really didn't have a clue of where that debris was going to land, and something that Skywara can do is actually take that debris out of orbit and bring it back down in a very controlled way, with a much less risk of crashing down into Earth and potentially harming people. Sonali, did you have anything to add on that?
Yeah, I think the space tug story is super interesting, because for a long time I know that people have been trying to solve this problem of how do we take small satellites and put them in a better orbit, because usually you just send multiple small satellites on a single launcher, right? So I think that's super interesting. But coming back to the space law aspects, I think we're only at the very initial stages now. When countries are talking together, we're figuring out the problems of if there are two satellites of different countries passing next to each other, what are the security concerns? Not just collision concern, but also can one satellite take data off of another? What are the laws and regulations we need to put in place? Do we have laws and regulations related to space traffic? How much distance there should be between two satellites? Can countries claim certain orbits as their own? And also, I think there has been quite a lot of demand for upskilling people in those kinds of areas. So space law and space traffic control management have been new courses that have been propping up everywhere. And I think it's super interesting to see where we're going to go, because this will require bringing in quite a lot of treaties like we have in international waters, but then slightly different because, international waters is on Earth, while we are going to go into uncharted territory now. So yeah, let's see where the future takes us.
And what's your opinion? What do you think will happen in the future?
I guess I'm hoping for a bigger collaborative environment when we are going forward. We are talking about these things, being transparent, but obviously there is a push. There will always be a push for different nations to have their own military and defense funding that goes into building some of the satellites. So I think there will be a lot of push towards making sure that these laws and regulations kind of also people are careful that the laws and regulations protect every single country's defense and security and integrities of the data that they send up into space and down into space. What I think is the future of satellite security, because it's a bit of a tricky one, you have to think of all the operating systems we're putting on the satellites, and especially in small satellites we have open source operating systems, so we can kind of upload a patch maybe every single time we see a flaw. There's also the fact that we are sending data down. How do you secure sending that data down? And then receiving that data, because we already have public key encryption on most of our internet. So how does a global future satellite-led quantum internet, how does it actually interface into the existing software? There would be multiple different flaws that we're going to find out, and multiple different laws that we're going to have to take into account, which I'm sure that we haven't thought of yet.
Yes, definitely. Yeah. And I think in more conferences and events that we go to, there's actually more space law panels that I'm, seeing more often. And, that is going to be a really big issue. You were chatting about downstream being a security issue as well. Paula, did you have anything to say about downstream space security issues?
It's a really good question. And it certainly is relevant for different nations and different data standards that exist across the world. It's something that we found through some of the projects that we run. Some of this information is private and some of it is internationally available. And, there are definitely challenges around data processing from satellites and where data is processed in the world and where it can be used. So it's definitely something that we have seen with some of our partner countries. But I think the real key is to build on, I think space is in a cutting edge space and there's a lot of innovation happening and there's a lot of leaders. But I think in terms of the applications, it's important to be aware of what already exists in all of the countries that we work with and building on top of that. Because it comes back to the point that you made as well about international collaboration. Space is an international asset, truly, just the same as the oceans or the forests or the climate. So it does really, I think that international collaboration when it comes to these things has to be a really, really key point across the sort of the West and the other continents in the South. So, yeah.
No, that's really interesting. And moving on a bit, Sonali, you said you do quite a lot of work in quantum technologies, as you've been talking about today. Would you mind telling us a bit more about what connection that has with cybercrime?
Yeah, definitely. It's interesting because you use the word key, so I'm going to pick that out. And so what I'm currently working on is quantum key distribution, as I mentioned. So just to give a bit of a background on why I'm working on quantum technologies. So what does quantum mean? It just means when you're working with particles which are the size of 10 to the power minus 15 meters. So if the atom is the size of a football field, then basically the electrons or the proton, the nucleus is basically like a tiny little football. And imagine that the atom is a football field and the electrons are that small, right? So we are basically working with those single particles, which are extremely small, and also they have very weird properties. They have quantum properties which are not the same as the classical properties. They are not the same as the properties of the material this chair is built up or I am built up, for example. So they're quite finicky. Now, quantum theory has been there for almost 100 years now, but right now we are basically in a position where we are actually manipulating single quantum particles like photons, which are the particles of light, or electrons, which are the particles that are in electricity. So our whole world is almost quantum now because there's electricity and electrons going around every wire. So with this quantum technologies comes this new term called quantum computers. So what are quantum computers? They're again better computers which are being built using single quantum particles. And these computers, currently they're not that developed. They're already there on the market, but commercial quantum computers could be there in 5 to 12 years. That's the prediction. And what these commercial quantum computers can do is they can just break through all of our public key encryption that exists all over the internet, all over any kind of data security in hospitals or financial institutions, banks, everywhere, in a matter of minutes. This usually takes normal computers a matter of decades, and that is why our security is currently safe, right? So what is the solution to that? How do we make our data secure? Because as Paula was mentioning, like everything in today's world is very information-centric. It's just heavy, the amount of information we use, and especially in COVID, all of us are doing virtual and remote stuff, and we need to make sure that our data is secure. So what we think is, okay, let's turn quantum on its head. Quantum can be used to hack into data, so quantum can also be used to encrypt data. And the way we do this is we send up a quantum source. Let's say that I have a quantum source and I want to talk securely with you. So I give you a receiver and I send single light particles over to you. What I can do is I can incorporate data into the quantum properties of these light particles, and you can take your receiver and you can receive those and say, okay, this is what she's seeing. You'll be able to measure those particles and find out what I'm trying to send you, a key. And then we can use that key for a secure communication. But because I'm using quantum properties of the particles, if somebody else were to eavesdrop and try to take one of the photons that I'm sending to you, if they measure it, then they're going to alter the wave function, as physicists tend to say. And so we will always know that somebody has messed with our data and how much data have they gotten access to. And so we can directly change our encryption and be like, okay, this communication, this key, we're not going to use. We're going to try another communication, find another secure key, and then go for it. So that's what we are trying to do. We are building a QKD payload, which we have already done. The second stage is because these QKD payloads are sending single photons out, the maximum distance these single photons can travel in Earth, where there's an atmosphere, or in fiber cables, is 500 kilometers. But what happens if I want to use a secure key from here to Canada? That's much bigger than 500 kilometers, right? So in that case, what I'm going to do is I'm going to use satellites as a relay. So let me send up a satellite into a low Earth orbit, which is around 500 kilometers. So the satellite sends down single photons to me. I have a ground station. The satellite goes over to someone in Canada, let's say that's Paula, and it sends down single photons to you, again, 500 kilometers. And most of the traveling of the photons is through space, vacuum. So they don't come in contact with atmosphere, and so we have far less losses. And so once both of us have these keys, we can kind of make some other kind of communication and say, okay, both of us have the same key now, and we can use it for a secure communication. And this was actually demonstrated by China first in 2016 by the MyCS mission. So they demonstrated a video conferencing that was secured by a quantum key distribution payload on top of their satellites. So the video conferencing was done between Austria and China. And so every other world is now, every other country in the world is now in a race to have their own quantum key distribution systems up in space. I think the ROKS mission is one of the earliest missions that is going to go up in space next year. We are also working with Canada on the KeySat mission. So we are providing a certain kind of quantum source to them, which is weak coherent laser pulse source, and they have a different kind of quantum source on the ground, which is an entangled photon source. So we are seeing these collaborations again. So because what's going to happen in the future is, if we want to talk securely with everywhere around the world, we need to have a constellation of satellites everywhere. And so we are already talking to Singapore, we're talking to Canada, we're talking to India, and making sure that all the wavelengths we are selecting now, every single component we are selecting now, has to be a certain standard and also interoperable so that they can talk to each other in the future.
And what does this mean to everyday people? You know, if there was an audience here, what would that mean to them?
I guess it means that if you're like, clicking on your phone and you're doing bank transactions on your phone, you're receiving an OTP, then if you're using quantum key distribution, that actually means that a quantum computer would not be able to steal your bank data. So you'll be happy to know that, right? Because otherwise, in the next 5 years, and cybercrime today, as I think like $600 billion industry. And so these syndicates could be storing our data, even though they don't have the capability of cracking them right now. They could be just storing it. And as soon as quantum computers are on the market, bam, all our data is out there. So for normal people, even though people might not realize how much reliant we are on security, on cryptography, we are. And it's just going to make our lives much more secure, easier, and so that there is no random disruption that happens because of a new technology in the market.
Definitely. And I think, there's, as you said today, there's so much happening behind the scenes that it's so easier just to go on your phone and send, a bank transfer. You don't actually know how much sort of security goes into that, and sort of, how it involves in cybercrime and your upcoming ROKS mission. I wanted to move a bit on now to more of diversity and inclusion, and chat a bit about the UK space sector. So over the last decade, the space has proved to be the UK's fastest growing sector, and it has trebled in size since 2010. Today, the UK space industry employs more than 42,000 people, and that's only expected to increase. And what do you think, the amount of people that work in the UK space sector has, and what do you think that means in terms of diversity and inclusion? Paula, can I ask you first?
Yeah, sure. I mean, I think that's definitely correct. I mean, the UK space sector is growing rapidly, and it means that there's, lots more jobs going in the sector and a lot more people coming from different disciplines and different backgrounds. We're three girls on here talking about satellite technology, which, is unlikely in itself, but here we are. And I think that it's the main thing about the UK space sector and its potential in terms of having different people involved and growing is really in the fact that we are lucky enough to have capability all across the space cycle. So in the industry, I mean, we call it upstream to downstream, right? So upstream is hardware, it's rockets, it's building engines, it is putting satellites into space and hardware. And then you've got downstream, which is more where someone like me is, and you're working on applications and data processing. And in the UK, as the sector's developed, what we've ended up with is clusters of companies, particularly in Edinburgh and Glasgow actually, where you've almost got every single part of a space supply chain there and companies that are able to work together. So, previously these missions, I mean, they're run by NASA or they're run by, Chinese space agency that have got all of this capability together. And I think that's the most important thing for the UK, and the most exciting thing about the UK right now is that we've actually just got the new spaceports, which is the newest addition to everything. So really the UK is really gearing itself to become ready to actually design, manufacture and launch its own satellites from our own regions, and you can do that through the partnerships that you have. And I think in terms of diversity as well, one of the things that I would really like to see is in terms of the design of space missions and their use cases, for that design to be more led by international communities to solve problems that are going on in developing countries. So with things like crop monitoring or drought monitoring, all of those sorts of things, there are satellites that are there right now, and they are solving problems, but I think there are real complementarities that could be found if we were to incorporate more user-led design from communities all over the world to help solve individual problems. So, even in terms of the sector, there's diversity, but I think in terms of the use as well, on Earth, there has to be a push for as much diversity as we can have in the applications.
No, that's really interesting. And definitely in terms of diversity and inclusion, as you were saying. Sonali, you are one of the founding members of SSLC, and that focuses on diversity. Did you have anything else to add to what Paula was saying?
Yeah, I think I would resonate with a lot of stuff that Paula said, and it's really nice to be in a panel where you're three women and you're talking about the amazing work that you're doing and contributing to the space sector. As part of the New Voices in Space working group of the SSLC, of which I'm a founding member, we instituted that by understanding that diversity was a problem in the UK space sector, as like any other space sector, and we wanted to figure out how can we actually change this, starting from a very young age. So one of the things that has a maximum impact on children is seeing role models that look like them. And often the UK space sector, because it is a small community, everyone knows each other, often we forget about the diversity of people outside that actually contribute to the UK space sector. So there's lots of researchers, the UK is actually pretty diverse. It has lots of racial and ethnic minority groups. It has amazing women doing amazing work in the space sector. There's LGBTQ communities and people with disabilities who are also in the sector. But things aren't always so easy for people who come from different marginalized demographics. So what we are trying to do is make sure that we are providing role models to school children, starting from primary, secondary, and high school education, making sure that space, diverse and inclusive space is a part of their curriculum. We're trying to also put together a mentorship program right now where people can just talk to a mentor who's already in the space sector, and that will make a lot of opportunities more accessible. So even like previously to the New Voices in Space, I worked quite a lot in the equality and diversity sector. And everywhere is the same story. There is no lack of motivation, but what there is a lack of is the opportunities and the access to these opportunities. Like there's a gap that needs to be closed. People want to find opportunities. There are some opportunities, but a lot of people miss out on them because there is an inequality in how these opportunities are directed towards people. But also there's another perspective on this, as Paula was saying. So if we have a diverse workforce, it makes sure that our policies are diverse and inclusive. It makes sure that the technologies we are uploading into space is diverse and inclusive. We don't want a repeat of like artificial intelligence on Ubers who can't see a black man's face, and so you have more black people being on the side of technology where it is actually bad for them rather than being used for the good. So we want to make sure that there is diverse communities, we are inclusive towards people, and I think small gestures go a long way. So for example, is the office temperature suitable for both men and women? I'm aware I'm talking binaries here, and that's not always the case, but office temperature has been set since the 1960s to the average body temperature of a man, and that needs to change. Like space suits, for example, have they been designed for women? Or just in the bathroom in the office, do we have period products for people who are menstruating, right? Those tiny changes could actually go a long way towards making people feel welcome, and once they feel welcome, there would be questions that they would ask, and we can meet that gap.
Definitely, that's really interesting what you're saying, and I think that we do need to change those in the future, and I think we're definitely stepping towards that. I think the last thing that I wanted to say on this is more about diversity, is that working in the space program is the space sector in the UK, you do not need to take a STEM subject to work in the space sector, and there's so many people that don't know that. Paula and I have a background in geography, and I go, now the work in the space sector, which I love doing. And there's so many school events that I go to and speak to children, and they say, no, I don't feel like taking maths. And I'm like, you don't need to do that to work in the space sector. And inspiring the younger generation is such an important topic, and I really think it comes into the diversity as well. Thank you so much, Sonali and Paula, for speaking to me today. I hope you've really enjoyed talking about satellites and what this has on the UK and globally, and what this could mean for us in the future. Thank you so much.